So today we're talking about graphing basic rational functions. So our goal today is I can find the asymptotes and graph my function. Okay, it's actually not too difficult today because I really feel like the steps are not too difficult to follow. So we should do great today. So let's start. All right. So first of all, what is this? That's what we're going to start off with. This is what is this? Okay. So what we're going to do is we don't know what it is. So this isn't how, I mean, you could do it this way, but I'm not. We're going to find a really quick way about doing it. But whenever we don't know what something is, it's nice to see what it looks like, okay? So there's a couple ways that we can do this. One way is we can put it into Desmos graphing calculator and see what it looks like. So you can do that now. Another way is to see what happens here. So I'm going to start picking some numbers. So I'm going to start with 0, and I'm going to start kind of in the middle. When I put a 0 in to my equation, I get 1 over 0, which doesn't mean anything. It's not applicable. I can't do it. It's an error. So this is an error, or it's going to be our asymptote. Okay? And then I'm going to put in a 1. So I get 1 over 1, which is 1. I'm going to put in a 2. I get 1 over 2, which is a half. Then maybe you can see the pattern already. So when I put a 3 in, I get 1 over 3, right? So I get 1/3. So 1/3. If I put a 4 in, I get 1/4. So here's my graph here. Let's draw a graph. And if I put a 1 in, I get a 1. If I put a 2 in, I get a half. If I put a 3 in, I get a 1/3. If I put a 4 in, I get a 1/4. If I put a 5 in, I get a 1/5. So notice this is not ever going to pass this line right there, the x-axis. So this shape of this graph is going to go like this, where the x-axis right here, I'm going to just draw it in red, is an asymptote. Okay? Now the same thing's going to happen over here. If I start picking numbers that are decimals, I'll start going up just like that. And that means the y-axis here in green is going to be another asymptote. And then I can put negative numbers in, and it's going to do the same thing. So when I put -1 in, I get negative, oops, that was not what I wanted. So when I put a -1 in, I get -1. When I put -2 in, I get -1/2. I put -3 in, I get -1/3. So this graph is going to look like this. That's its shape. So notice we have a new shape here, and we have two asymptotes. One that goes up and down, known as vertical. This is vertical. And one that goes left and right, known as horizontal. Okay? So that is our shape of our graph. So let's go ahead and walk through some steps. Okay. First idea here is I have two types. They're very similar. Type 1 right here. Notice there is only one x. Okay. And in type B is we have two x's, one on top, one on bottom. And those are going to be graphed slightly differently. Slightly. Okay. So step 1 is we're going to find the asymptotes. Okay. So we're going to find the asymptotes. That's step 1 of graphing. And so we're just going to end up doing just step 1 here because example 1 says find the asymptotes, the vertical and the horizontal. So when there's only one x, our asymptotes are as follows. So we're going to take this right here. We're going to set it equal to 0. So 2x minus 6 equals 0. We're going to add 6. So we get 2x plus equals equals 6. Right off the 2, we get x equals 3. Okay, and then this is our vertical asymptote. Okay, our horizontal asymptote is right here, y equals 2. And this is our horizontal. Okay, so what I want to have you see here is x is right, so we're going to go right 3. I have an asymptote right there, and then y is plus 2. We have an asymptote right here. And then from here you could probably just guess the graph, it's not a big deal. But that's going to be step 1, and that's how we find step 1 when we graph, is the asymptotes. And a lot of times that is the most important part of the graph. Okay, when it looks like this, this right here, the screen part, is still the same. So to find the asymptotes, we're going to do x plus 4 equals 0. So x equals negative 4. And that's the vertical. The horizontal asymptote, don't forget if there's no number in front, we could put a 1, is that right there. So it'll be y equals 5 over 1, or just 5, and that's the horizontal. Okay, so if we were going to graph this, we got left 4 for negative 4, and then we have up 5 for that. Okay, and that's step 1 of graphing, and so the first problems ask you to just do this. Notice the difference, 1x, 2x's, and so notice the difference is in this purple. Okay, and that's it actually. So on example 3 we have the 2 different types, so we're going to do step 1 again. So step 1 is we're going to take this denominator and set it equal to 0 and solve. And that is our vertical asymptote. Next we have plus 4, and that's our horizontal asymptote. So that's y equals 4. I'm going to highlight that. Okay. Then step 2 here is going to be plot asymptotes. Okay, so when we graph this, because we're graphing now, we're going to plot the asymptotes. So x is 3, so 1, 2, 3, and that is the vertical. 1, 2, 3, 4, that is the horizontal. Okay, and from here you could probably just guess, and that would give you a B probably, or a C, I mean. But we're going to make sure this isn't a guess. So then step 3 is we're going to do a table. Okay, so our table of values is going to be x, y, and this number right here, the 3, is where we're going to start out. So this was what's going to go right there. And we're going to do 2 above it and 2 below it. Now 3 is an error. Okay, so we can't do 3, but we can do 4 and 5, and we can do 2 and 1. Okay, so here's my problem. I have 4, and I'm going to write it like, I'm going to write it over here. I apologize. So I'm going to put a 4 in. So we have 4 on top, divided by, so I hit the divided by button, parenthesis, 3 times, I'm putting, let's put a 5 in first, 5 minus 9 plus 4. And then let's see if that'll actually, no, I need to write it like that. I forgot my parenthesis. So when I write like this and I enter in the calculator, it's going to give me the right answer. Or you could just do it in your head. So I put that in the calculator as it's written, and I'm going to get 4.67 because it'll be 666 repeating. Then I'm going to do the same thing, but I'm going to put this 4 in. So I'm just going to highlight here in blue. Okay, so these are the same, and I'm just putting this in here, but it's going to look like that in my calculator. So I'm going to put the 4 in my calculator, hit enter, and I'm going to get 5.33. Then I'm going to put a 2 in, so 4 divided 3 times 2, minus 9 plus 4. So I'm going to put that in the calculator. And I get 2.67. Now I'm going to put a 1 in. And I get 3.33 repeating. So notice what I did there. I plugged those in, and that's how we put this in the calculator. Okay? Now we're going to plot the points and draw our shape. So 5 and 4.67. So 1, 2, 3, 4, 5. 4.67 would be about right there. 4 and 5.33 would be about right here. We have our graph. Now if you just guessed, you could probably get that same shape. Same thing over here. We have 2 and 2.67. So 2 and 2.67. And 1, and it'll be bigger, 3.33. And then now we can draw our graph. Now notice how our graphs look. It starts off parallel and then curves and goes parallel to the other. And that's how it's always going to look. So you could actually guess a lot of these and get them right because, well, they look like that. Once you have the asymptotes, you can almost guess. Now if you want an A, you need to show all this work. Okay? And I'll show you more about a B-level work next time because we're going to use technology. So the next one here, this one's going a little quicker here. So step 1, we're going to do the asymptotes. Okay, so this is 2x plus 4, so we have 2x plus 4 equals 0. Subtract the 4, so it's negative, and then we're going to divide off the 2. We get negative 2. And then our other asymptote is right here. You can't see that. I apologize. I'm going to just kind of go like that, okay? So it's 2/3, so y is equal to, or sorry, 3/2, or 1.5. And that is our other asymptote. So we're going to graph this. So we're going to put a negative 2 in, 1, 2, and I'm going to, right, because x equals negative 2, it's going to go left 2. This is up 1.5. Okay, and then we want to make sure we do this right, so we're going to put some points in. So we have x, y. Because sometimes if you don't put the points in, you'll actually get it wrong. So this is an error, right? Because if we pick, again, this, we're doing the same number. And then we're going to graph this, okay? So I'm going to put negative 1 and 0, negative 3 and negative 4. Okay, so I put a 0 in, I'm going to do all the math in my head, I'll get negative 1/4. When I put a negative 1 in, I get negative 4 over 2, so negative 2. When I put a negative 3 in, I'm going to get negative 10 over negative 2, which is, what, 5? Yeah, 5. And then negative 4 is going to be negative 13 over negative 4. Negative 4. And then on negative 4, I get 3.25. Now, I did those in my head. If you'd like to put them in the calculator, it's not hard. You do 3, parenthesis, 3 times what you're going to put in, so 0 minus 1, divided by parenthesis 2 times whatever you put in. It has to be the same number twice when you do it. So when you put this in the calculator, make sure you just change those numbers out and hit enter, and it'll get you the same. So we're going to plot this. We have 0, negative 1/4, and then negative 1, negative 2. So it'll be like this. So notice it switched spots. Then we have negative 3, 5, and negative 4, 3 1/4. And I'm running out of time here, and I want to do domain range. Okay, I forgot to do domain range. Domain range is really easy. Notice these graphs go left forever and right forever. So it's going to be all real numbers for the domain, but the asymptote, so but negative 2. The range, again, is super easy. You're going up forever, down forever, so it's all real numbers again, but it can't be that asymptote. It jumps, kind of hiccups. The asymptote is 1.5, and that's it. So notice asymptote